Hey everyone, my name is Venelin, and in today's video I'm going to show you how you can build a PyTorch dataset and use that within a Lightning data module so we can train a model or fine-tune a model with PyTorch Lightning. Let's get started. In the last video, we've just installed PyTorch Lightning and the Transformers library, and I've shown you how you can use the Electra tokenizer on a dataset called GoEmotions. In the next couple of points, I'm going to first build a PyTorch dataset and use that into a PyTorch Lightning data module. But before all of this, I'm going to basically transform the problem a little bit, since we have a couple of we have basically some comments, and those comments can have one or more emotion associated with them. I'm going to just take the most common emotion that was annotated for each comment and use that as a label for the particular comment. But first, there is a newer version of PyTorch Lightning, and I'm going to start by installing this. And then I'm going to run through all of the code from the last time, and this will go ahead and install the PyTorch Lightning on the newest version. So if I go to the bottom of this, I'm going to start with converting the data into a single data point or single label per each comment. And here I'm going to just take, let me just do this. And here I'm going to go through the data frame that we have, which is again these annotations from the GoEmotions dataset. And once all of this is complete, I'm going to continue. Alright, so now that the notebook is again executed, I'm going to show you just as a reminder what we have here. And we have the text, the ID of the comment, and multiple people that annotated the particular comment. And we had 27 different emotion categories and a neutral category. So for each of those, I'm basically going to take every annotation. So I'm going to group the comments by their ID. And here we can take the text at the first position of the group. And I'm going to show what this looks like here. So we have this text for this particular comment. And for each comment, I'm going to take the ratings for it. And to do that, I'm going to use group of the emotion categories. And remember that these are the categories that we have for each emotion with the neutral category. And I'm going to print those just for you to see. So we have each individual category assigned here as a column which contains 0 or 1. And I'm going to basically sum the rows. And as you can see now, we have this vector with approval as a category assigned by the, I guess, the two annotators that did this comment. And I'm going to take the maximum value of this, and this will be 4, since this is the fourth category. And if I go back again, just for you to see this, and I'm using the Vim bindings here. So this is 0, 1, 2, 3, 4. Fourth category has the maximum number of annotations here. So this will just take the index of that category. So this is great. And this will be the emotion that this particular comment has. So I'm going to take the texts and the emotions from this. And the text is going to be this. And the emotion is going to be this row here. And if we leave this one running, this should take some time to go through this. And after that, I'm going to show what is the result of it. But we can basically do a data frame which contains the texts as a text category and the emotions as an emotion category. So this should give us the data frame. And once this is complete executing, it's a bit slow, but you did do it only once. So you should be able to go through this. And then I want to do another bit of pre-processing. I've taken this from the original example project from the Google team. Not this one, but this. Let me just take it. So this is the result now, but I just want to add an emoji to this. And this is basically an emoji map, which is once again taken from the original GoEmotions example project. And to use this map, I'm going to take the emotion categories and assign a new column right here, which contains the emoji that is represented by the following emoji right here. So you see the result of this. So I'm going to add the emoji column, and then this is a bit of complicated stuff, but not really. So I'm going to take the emotion and I'm going to map the emotion to the name from the emotion categories. And then I'm going again to map the name to the emoji map. Let me run this. And the emoji map is not defined. Let me define it. All right. So now if we have a look at the text data frame, this should give us this, which is great because we now have an emoji associated with each text that we have right here. Just a little nice thing, I guess. All right. So next I'm going to show you how you can create a dataset. So now that we have the data frame in a format that will be useful for the text classification that we're going to do, I'm going to instantiate or create an emotion dataset, which is inheriting from the PyTorch original dataset. So let me just check the imports, and yeah, I'm missing those. So in order for the dataset to be available, we need to import from Torch utils, and I'm going to also import the Torch module. And another thing, well, let's just ride with this. So I'm going to show you how we can build the dataset. So to build the dataset, we need an init method, which is going to be the constructor for this. And here I'm going to pass in the data, which is a data frame, and the tokenizer, which is going to be the Electra tokenizer. I'm going to create the fields for those. I'm going to override the length method, which is going to just return the length of the data frame that we have. And next, I'm going to override the get item method, which is passing the ID of the current item that we are going to look at. So I'm going to take the row, which is associated with this ID, and I'm going to create an encoding with the tokenizer, and I'm going to pass in the text, a max length of 64, which is taken from the exploration of the tokens that we had right here. So 64 should pretty much cover almost everything. Next, I'm going to require truncation. Padding will be to the max length, so all of those will be at 64. We want the special tokens added. We want the return type token IDs to be false. Token type IDs to be false. We want the attention mask. And we want the return tensors to be PyTorch tensors. So this is great. And the final item is going to be just a dictionary, which contains the input IDs. I'm going to flatten this. The attention mask, again from the encoding. Then for the label, I'm going to convert the emotion, which is again this label right here, into a tensor, torch tensor, that is. All right, so now that we have this data set, let me try it out. I'm going to create an instance of it, passing all of the data. And first I'm going to print the length of the data frame. So this should match the length of the text data frame. Let's check if this is the case. So this looks all right. And next I want to just try out to iterate over the data set. So an item should have label, and it should have input IDs, and I would just want the first 10 of those. Let's look into those. And yeah, we can see that we have the input IDs right here. This is the special classification token, and then the rest from the text. And we have the ID of the first example, which is this one. So this looks like it is working. All right, so next we are going to build a Lightning data module. And the purpose of this is to be able to adapt our own data set to what PyTorch Lightning is giving us. And to do that, we basically need to import PyTorch Lightning. Let me start with that. And I'm going to import it as PL, which is the convention. So next, I'm going to build the emotion data module, and this will inherit from the Lightning data module, not the Lightning module, but the Lightning data module. And here I'm going to pass in some parameters. We need the data, which is going to be a data frame, a tokenizer, and I'm going to pass in the batch size. And yeah, this is a bit hectic. So let's try it out like this. All right, so I'm going to take the data, the tokenizer, and the batch size. So one of the methods that we can override here is the setup method. And for this to work, I need to import the optional from the typing hints. So let's go ahead and do this. From typing, import optional. All right, this should do it. And now, why do we need this setup method? Well, this is a place where we can do basically some pre-processing of our data. And in our case, I'm going to split the training, the testing, and the validation set right here. So to do that, I need to import the train test split from skwarn. And for this to be reproducible, I'm going to do PL seed everything to 42. So this will basically seed all the random numbers that we have. All right, so here I want to split the data into train and test. Train, test, split. So data, I want the test size to be 20%. And I want to again split the data into validation data frame and test data frame. Train test split on the test data frame with test size of 0.5 or 50%. And then I'm going to assign the train df here. This will be the validation data frame, and this will be the test data frame. So this is great. And next we need to prepare basically all of this into data wallers for each individual stage or step of the training process. So PyTorch Lightning is giving us this train data waller method, which needs to return a data waller, which we've already imported. And this accepts a dataset, which is going to be the emotion dataset that we created. This will get the train data frame, and this needs also the tokenizer. This is why we are passing it in. Next, we need a couple of more parameters. So I do want this to be shuffled because this is the training data. I am going to pass in the batch size, which is going to be the batch size that we are passing to the constructor here. And I want the number of workers to be the number of CPUs that we have. But to do that, I need to import the OS module. And to get the number of CPUs, I just need to call OS CPU count. And this might be different on your machine, but on Google Co-op we have 2 CPUs or 2 cores, more likely. So os.cpu count should give us this. And then we need to create a validation data waller and a test data waller. And both of those are not required. And as a matter of fact, the LightningDataModule is not required for you to train a model with PyTorch Lightning. But I guess those are good practice, and they encapsulate very well the data that you need to create or adapt for training your model. And one nice thing about writing those Lightning data modules is that you can swap your dataset by just writing a new Lightning data module and reuse your old models to train on this new dataset that you have. So let me continue with this. And I'm going to take this and I'm going to replace the shuffling. I don't want shuffling into validation data water. And here I'm going to pass in the validation water data frame. And this will be the test data water. And I'm going to just replace this with the test data frame. And this is pretty much it. Now we have this Lightning data module. And let me just create an instance of it. So this requires the text data frame, the tokenizer, and let's say a batch size of, let's say 24 or 32. So we don't have the tokenizer. Oh, this should give us what we need. All right, so just to test this, I'm going to call the train data module train data water, and this should return the data module. But yeah, just to try it out, we need to call the setup method manually, because nobody is calling this. Num, I have a typo. All right, so a lot of mistakes here. Workers. I should have taken the autocomplete. All right, let's try this once again. Num. All right, num workers. This should be correct this time, I guess. Workers. All right, so this is finally returning the data module. And if we print this batch, yeah, this should be working. Let me break this. And let's check the length of the batch first. Okay, so we have 3 items in the batch, and those should be the input IDs, the attention masks, and the labels. Huh. Why? Let me just print this. And what is the size of this? It's 32. Yeah, oh, so the batch length is the number of things that we have in the batch. So we have the attention mask, the token type IDs, and the label itself. But each of those should have, yeah, 32 items. Let's just check that this is the case. Yep. And the same thing should be true for the token type IDs. And the last thing should be the label. The label, yep. Do we have the token types? Input IDs, yeah, right. Let's just call it input IDs. call this the attention mask. And run this. Yep, so this is pretty much what we expect. 64 is the maximum number of the sequences that we get, that we want, and each batch should have 32 items. The same is true for the label, of course, and we have 3 items in each batch, which are printed right here. So in this video, we saw how we can create a PyTorch Lightning data module. And once again, this abstracts away your dataset in a format that is, let's say, more general. And in the next one, we are going to build our model using Lightning module. I'm going to show you how we can basically just fiddle a bit with the original Electra implementation from the Hugging Face Transformers library. And I'm going to wrap it into a module with PyTorch Lightning. Thanks for watching, guys. Please share and subscribe, and go visit ML Expert to prepare for the machine learning interview. Have a good day. Bye bye.